Hello, good morning. Thor is here, and we've just been looking at the news from Iceland about the recent earthquakes, and we thought we'll share that with you. So, Thor, what's going on right now? There has been some earthquakes that have been somewhat closer to Reykjavik than the earthquake swarms on the peninsula over the last few years. What's the story? Do you know more?
Well, I know a few things, but you see that there is always earthquakes in Iceland. So this is just the seismic map over the last week or so for the Reykjanes Peninsula.
Right.
And it's not heavy-duty seismic activity, with the exception of this swarm that took place here, basically in Svínahraunsbrunni, which is just west of Hellisheiði power plant. So this is very close, basically adjacent to the main power plant that supplies Reykjavik both with electricity and hot water.
That makes it a little unpleasant, doesn't it?
It does. But you can see here that most of these earthquakes are typically sort of less than 6 kilometers depth, 7 kilometers depth. There's a few things out here in the Reykjavik which we're not seeing maybe quite well. So there's also some activity offshore.
So just for those people not so familiar with this type of map, the radius of the little circles there, the size indicates the strength of the earthquake. So
yes,
these earthquakes,
the magnitude of the earthquake.
Yes, the magnitude. So the ones, these guys here closer to Reykjavik now, the capital here, they are of a bigger magnitude than those guys out there.
Yes,
these are kind of small.
So smaller the circles are, the less the magnitude is. And then you have, like as you can see here, I should notice that this is from the Icelandic Met Office.
Mm-hmm.
And then this is, all of this stuff is data gathered by the Icelandic Met Office, processed by the Icelandic Met Office, and this is their presentation of these data set, and this is available to everyone.
Yeah.
So people can basically log in onto this here, and they can have a look at these. And there are I'm not sure, there might be an English version of this, but this is the Icelandic version. But people can figure out what these things mean.
Yeah, Dupi with depth, I guess I can just about make that work. This one here.
Deep is depth and length
is length. It's longitude.
And length
is the latitude, exactly. So.
And then 3 feet is 3D.
Breitengrad in German. Yeah, so here you go. And
anyway, so it's interesting to look at. But what has caught people's attention in recent times is this seismic swarm right here.
How big, or what's the magnitude of those guys?
The biggest one here is 4.5, which is actually fairly big for an area which is generally under extension and fairly thin crust. So typically the biggest earthquakes we get in this region is like maybe between 5 and 6. Yeah. Occasionally we might get one which is larger, but that's very rare. So 4.5 is actually getting up there, even though there is an order of magnitude difference between 4.5 and 5.5.
Yes, but 4.5, I recall those that I experienced, they start to get unpleasant. Things fall off the shelves, furniture move, and some of the buildings might actually have the first initial cracking and things like that. So it starts to get serious at that level, and of course you're right, higher magnitudes is an exponential scale, but wow, 5.5 can actually be structurally quite damaging to settled areas already. So what's the risks for the outskirts of Reykjavik and Reykjavik itself at this point?
Not huge. I mean, it may cause things to topple over. Mm-hmm. And people will shake. And of course, depending on the individual, people respond differently to these kind of motions and movements. Mm-hmm. If you have loose things around, they can fall over. So we don't expect any collapse of buildings, or there's not going to be any major fracturing in Reykjavik, but people could be shaken up a bit.
Yeah, there could be some local effects. I would think as well. This is not the level at this point. If it gets stronger, that's a different issue.
We should remember that Reykjavik has very high-grade building codes. So houses in Reykjavik are built to withstand earthquakes of magnitude 6 or greater. So that's just that.
That's a very good thing to have in mind.
Yes, and all of it, all the concrete is still reinforced, even though it will crack. It's not going
to topple immediately because of the strength of the steel. And
yes.
I mean, we know from Second World War air bunkers that were made with steel and forced concrete. You can't get rid of them. They're still standing to this day because you can't even blow them up.
Yeah, so that, I mean, like I said, people may find the movement uncomfortable, and you might have valuable things fall down and break, which could be, of course, an emotional loss.
So let's hope it stays exactly as you say, like this, and it doesn't get stronger, but hopefully also it doesn't move much further to Reykjavik. But what, and this is more the geological kind of aspect of this little chat. But what is causing it, you think?
Let's look at this map a little bit. So here we have Blåfjell, which is one of these volcanic lineaments on the Reykjavik Peninsula. And I don't know whether people can make it up, but there's a little dot there, and there's a little dot there, and there's another one there. Those are actually cone rows, which erupted in the year 1000, produced a lava flow field, which is over here called Svínahraunsbruni, or the Christianity lava flow, because it ran when Iceland was debating in Parliament whether they should become Christians or stay heathen. And the heathen followers were kind of brought the news of this eruption that was moving towards one of the farms in the neighborhood, and they said, no wonder the gods must be outraged at this activity that we're undertaking here. Said the heathen followers. So meaning that this whole thing bringing Christianity was
a bad thing.
Oh, yeah.
Terrible.
But then the main leader of the heathen group stood up and said, "At whom were the gods outraged when the lava we are now standing on was flowing?" End of debate. And since then, Icelanders, have not been, the tradition of Iceland has not linked these kind of events to any kind of, religious things
or higher power. Because that's what often happens in disaster cultures. That there is this belief that events like this are, linked to human behavior and activity, and it's good that Iceland cleared this up already back in the day in Viking era, if you will. So.
And I don't have the solution for what type of earthquake it is, whether this is actually extension or strike slip. I have a sneaky suspicion this might be strike slip. There's a fairly northerly direction of.
There is a bit of a direction, isn't there? Yes.
Alignment on the seismicity, even if you zoom in, you can sort of see that. But it's interesting. It is actually at the northern end of this volcanic lineament here in Blåfjell. Yeah. And we should remember that Leitin, the crater Leitin is right there. That's the crater that actually produced the lava that flowed out here and then all the way to Reykjavik. It is the only the eruption that produced lava that went in with the city limits of Reykjavik. So,
and that's, geologically not so long ago. So
no, that's about 6,000 years ago or so. And even though these might be purely tectonic earthquakes as matter stands now, I think what is signifying is that this area is active again. It's preparing for some more events. So this could be just one stage of that preparation.
It could be, but I guess some people will ask the very, very direct question: Is there magma down there?
We don't know. It could be. We cannot rule that out. But there's no inflation on nearby stations. There's nothing indicating that magma is accumulating. At least that's shallow depths. We don't know what's happening deeper down. But to me, this is just part of the pattern that we've seen on the Reykjanes Peninsula. There's seismic activity increasing. There's seismic activity in Reykjanes and offshore Reykjanes, and there's seismic activity in Hengil, and so we should be watching this carefully and also thinking about, okay, if something happens in this region, if we get eruption in this region, what is it that we need to do to protect infrastructure like, let's say, the power plant, which is just there.
Yes.
What can we do and what could we do in case of a worst case scenario, and to make sure that these kind of events have a minimal impact on our everyday life. And this is something we really need to start thinking about and preparing for. Not wait until the thing has happened. Do some preparation.
Be mindful about what we could do already at this point. I'm just realizing, Thor, sorry,
but also, just one thing, before we go, it's just an educational thing. Now take a look at these deaths here. This is right around between 5 and 6 kilometers, the maximum depth of these earthquakes, these large ones. And that's also interesting because that is the brittle ductile transition in the crust. So the above this depth here, 5 to 6 kilometers, the crust is brittle. It actually will break fairly, and you can build up stress in it. And
when under pressure,
you build up stress, and then it snaps, and you create then fairly large earthquakes. Below this depth, it actually is in a more ductile form. So it actually, if you apply the stress to it, it will actually give away
a little bit. Yes.
Yes, and it will take much more sharper or faster, force.
It will take punishment.
But higher strain rate.
Yeah.
To cause it to fracture. So you really have to put the applied force on it really fast. And we see there's a few earthquakes down here. And quite often we do get earthquakes down here, but they're typically very small. And they can extend all the way down to 25 plus kilometers. But what they are telling us is that something is actually causing a fairly sort of rapid
movement that
deformation
will shear the rock.
Yes, and that will actually
beyond its limits.
Yes, it will actually break this ductile part. Mm-hmm. So, and those earthquakes in many ways are more interesting because they are really telling us that, at least my interpretation of it is that those earthquakes are generated by magma injection into the lower ductile part of the crust. And quite often you will see these as very distinctive paths. And just to demonstrate that, we can actually just zoom out here. And
I was just realizing just at the before you kind of go away completely, I just realized that the road where the earthquakes are occurring is actually the road to your house. So you are driving on this every day.
Yes,
so.
Yes, it is. But you can see there are clusters over here by Langjökull in the western.
Yes, that's quite big as well, actually.
Yes, and that's an interesting cluster, and you can see this actually on a very nicely faulted area right here on the margin of the western volcanic zone, and the activity continues in Snæfellsnes. This cluster, if we take a longer period of time, you will see this is a very dense cluster of earthquakes that just keep happening at the same place and roughly the same depth, 15 to 20 kilometers. So clearly, this I think is clearly indicating magma is accumulating under this area at roughly about 20 kilometers depth. And what we know from studies that have been done on, the few studies that actually have been done on the rocks from Snæfellsnes, that if you look at sort of diffusion timescale or diffusion studies that indicate timescales of things, magmatic processes, you start accumulating magma at 20 kilometers depth. When it migrates up to 10 kilometers depth, there's a very short time until next eruption will happen.
So yes, I was about to say at 20 kilometers I would still be rather relaxed, but once it shallows into the upper crust, then
now I'm going to do one thing here. I'm going to change these to just so we get a little bit nicer cluster. We can do it like this, and then you will see a lot of things.
Yeah.
But I want to focus on this little cluster here. This is where the dike for the Holufen 2000, or dike, the seismic swarm, I should say, for the Holufen 2014-15 began. Right above this location, that's where it started, and then it went here, this way, and out there. So if the seismics will migrate it this way. And if we look at this in 3D, you can see these earthquakes are all down here. And they are below 15 kilometers and they extend almost down to 25 kilometers. And this seismicity has been ongoing at least since 2010, maybe longer. I haven't really investigated. It's clearly indicating pathway of magma.
There's something moving.
There's something moving
there,
up and feeding up.
You can see it, but
and then it
deep.
moves up. And yes, it's still deep in this case. And then when it starts to get shallower, then it's
once it would, yes. Then you need to be concerned once you're moving.
But it is still moving.
5 kilometers depth. Then it gets kind of. Then you have to raise the alert. But at this level, if it's kind of at this depth, I'd be personally relaxed. I agree.
Well, I'm not relaxed because this is part of the preparation.
Well, relaxed as in you don't have to take active measures. But
No, it's not telling you that an eruption is happening tomorrow.
Yes, that's exactly it. But
or neither are the earthquakes near Hellisheiði.
Mm-hmm.
I mean, but what they're telling us is that these areas are continually active in sense of unrest or magmatism, and this is part of the way they prepare for eruptions. And therefore, we should be paying more attention to actually what these things are doing prior to we have events. Because this is when we learn about what's happening during the time the volcanic systems or volcanic lineaments are actually preparing for an eruption. And if we ever want to be able to predict an eruption, we need to understand this.
We still have a long way to go before we can predict eruptions, but I entirely agree that we need to actually learn and understand these things. But coming back to this particular place for a second, wait a second, Thor, be so kind. This was in the middle of nowhere, kind of.
It's in the middle of nothing.
Well, but there's no settlements or anything there.
No.
So that wouldn't be necessarily a place where I would kind of, have the biggest worries about. While on the Reykjavik Peninsula, there we have, 70% of the Iceland's population.
Yes, totally agree. But, worrying about what these things impact these can have on populations is one part of the equation.
Mm-hmm.
And in order to be able to respond better to any kind of a disastrous events, we need to understand them better than we do today.
As such, absolutely, yes.
So, and different windows provide us with opportunity to study different things and different parts of the system that it generally is feeding magma towards the surface in Iceland. And we need to use every opportunity that we get to actually study those things, because we may not always get those windows when we just want them.
And I am in full support of that.
Fortunately, these things are, data that are stored and accessible, and one can look at them also afterwards, so we can actually go back in time to look at things, and we should do more of that. And this is why this monitoring is important, because it does provide information about potential what might be happening, but also provides data that for fundamental research that we should be funding and doing much more of than we actually do. And to be blunt, that research should not be on the responsibility of the monitoring institution, because typically those who are in charge of the monitoring, they have more than enough on their plate.
They collect the information and collect it and catalog it.
Of course,
They
should be part of the whole equation. And like we've often said, science is about collaboration, and that's what we need to promote in a much more efficient way than we're doing right now.
Yeah, I was about to say that this is actually good that we have access to all this, because to assess long-term baselines, which is the way to understand any anomalies, is fundamental here.
Absolutely.
And I am actually very happy with this catalogue there. So,
But if you think about if we have a catalog like this for, all of the potentially dangerous events, if we have also, not just for seismicity, we have it also for the deformation on a denser network than we have today. We also have it in terms of how eruption progress. We have good documentation of how eruption behave. We then might be able to look back on those records and actually start to identify certain patterns.
I would hope so.
Yeah, and so forth. And same with the geochemistry. Same with the degassing. And because what people don't often realize that when we're looking at magma degassing, we come from slightly different angles to the problem. There are some people which are just measuring the flux from the volcano, and that is fantastic, and that's also a good part of monitoring and all that thing. But there are issues with those measurements, just like there's issues with any kind of measurement, and they're not perfect either. And for example, in Reykjavik, we had severe CO2 contamination just from the vegetation burning.
Absolutely.
And that will throw off any kind of CO2 measurements for Reykjavik, unless we can
separate the volcanic from the organic.
Yeah, and that's what, for example, Tobias Fischer has been doing, and they have identified a way to do separate these things. So that's an important learning.
Absolutely.
And so what we need is to be very clever and actually construct an open database which is open to everyone with all of this information, not only just one aspect of it, but everything that is done on these
which would then allow to do big data science, i.e. do these long-term comparisons with a lot of significant volume of data behind it. I mean, partly this is the concept in EPOS, the European Plate Observatory system.
This is nothing so
it's nothing an individual can do, exactly.
No, and it's not my idea. This is, people have realized this for a long time. But the question now is more for us to actually convince the authorities to actually support this kind of activity.
It's fundamental, and it makes me kind of think of this little kind of story. We are here in Uppsala, and there is a lot of people that have done research for a long time. There's weather stations that weather things for hundreds of years, even if at the time people didn't quite understand. Yeah. And then, of course, people were starting to measure the uplift of Scandinavia already in the 1700s by marking rocks and then seeing sea level change. And of course, now we have this record going back hundreds of years, and this is phenomenal. So this is now, of course, a digital kind of era, and we're moving forward with this. But the concept of keeping records is, even if we don't always use the data at the time, is I think, a very important point. And indeed, I can see that it's hard to convince governments and protection agencies sometimes to collect these data if they're not immediately.
We need to be more clever about it, because this will help save money in
the long run, because we have the information, and information, as we all know, is allowing us to do some measured responses rather than just guesswork.
This is Askja.
Oh, that's a very different beast, isn't it?
Yeah, there's a fair bit going on in Askja, and a lot of.
But there has been on risk for quite some years in Askja as well.
But that comes back to the very important aspects of things. The volcano timescales are not the same as ours.
Very much correct.
So a second in a volcano's life could be years in our lives, and that's and what Askja is doing now, there is no doubt about it. It's preparing for a big eruption. Maybe another 1875
style explosive eruption. But it will take some time. It's not gonna.
Most likely, but we don't know, because this is the first time we are monitoring Askja preparing itself for an eruption.
Yes, but what I guess my point is, what I have in mind is that people might be worried when they hear us say things like this, but this is not indicating that Askja will erupt tomorrow. So this is these type of volcanoes, these caldera, silicic volcanoes, they need quite some time to build up.
We would expect to get a fair bit of fair warning.
Exactly.
Like how long is that warning? What's the form of that warning? We really don't know. And will we recognize that thing as a warning when it comes?
I really hope we do. So it should
that,
be years ideally, but
these are all things which are uncertain, and therefore, monitoring it and following what's going on and what they've been doing at Askja is actually really, fantastic, not only data gathering, but also a lot of really, really good studies that have been done in recent years on Askja, both in terms of the plumbing system, the magmatism, and also in terms of the eruptive activity. But that approach is not only applicable to Askja, but that's applicable to all our volcanoes.
And this is where the issue is, because this is making volcano monitoring and surveillance also an expensive effort, because there is manpower needed to do these things, to establish these databases.
But what is expensive?
Well, this is the big question, isn't it? So, but
see, if you look at just the numbers that actually went into building the berms to protect the Blue Lagoon, entertainment facility.
Yes.
Which is an important entertainment facility.
It's the most important entertainment facility in Iceland.
But it is a pleasure paradise.
It is. It's a Disneyland kind of thing.
Yes, exactly. The power plant of Svartsengi, and also the town of Grindavík. I think the numbers that I heard last time was like 12 billion Icelandic kroner.
What's that in?
And you divide that by 120 to get the dollars.
Okay.
I can't really do that.
It's still a lot of money.
Divide it by 100, then
Yeah. How many billion in Iceland?
12 billion.
12. Oh my God. Yeah. Then.
Okay, it's a lot of money.
It's still a lot of money.
And you would say this is really, really expensive.
But of course, this is balanced against what the value
hang on.
Yeah.
This is what people say. We spend a lot of money. This is really expensive. Is it really worth it? And I say yes, because this is less than 1% of what the infrastructure that it is protecting is worth.
And that is crucial. I accept that point very much so. I mean, this
is and the same thing goes for when we always say the science is expensive. And it's almost like, science is not really worth it, because, it's not...
It's the blue sky science that I think people misunderstand, because we are collecting information about the world to understand it better until we suddenly have these moments where we can use all of this.
But that's a foundation for anything
But
else.
This is what somebody who has to run a kind of an annual budget in a science foundation might not necessarily see the same way, because there the question is it useful?
I understand that, but then, and at the end of the day, this decision is not down to individual politicians or individual funding agencies. It's actually down to the people.
And it is down to arguments like what you just made, that if we can actually clearly demonstrate, because this has been argued that at Pinatubo, for example, there was a similar argument about all the costs that were associated with the volcano monitoring, but then all the things that were saved, or the evacuation of the airbase at the time, the US airbase, that this was done in time, and that there was a low number of casualties at the time. All of this has to be measured against it, of course. So, and I take that point.
Yeah, and then you have to also ask yourself, what is our lives worth? What is our community worth?
Yes, and I hate to be so cold about this, but when you talk to people who work in hazard insurance or disaster insurance, there is a value for a human life, and it's approximately $2 million in an air crash, for example. That's the kind of
I understand, but
I know it's terrible.
I don't really care about what the insurance companies think about these things, because, like I said, at the end of the day, it's down to the society itself. It's down to
you have to value these
the
things
community
somehow,
itself
and then you have to measure it. I see.
And if you want the community to make an educated decision about these things, you need to educate them about that, and which we are doing right now, and then people can sort of make up their own. How far do they want to go, and what is acceptable risk, for example? What and how far do we go in terms of protecting things? Because there's going to be a limit. We can say like, okay, let's spend 1% worth of what the infrastructure costs to protect it. If we go beyond that, then we just have to rebuild. And those are kind of decisions that should not be made in dark rooms in parliaments or in back rooms of monitoring institutions around the world. They should be made by the people.
You think we should have elections about the percentage of science funding in
Not
the
necessarily.
country? I wouldn't mind, actually.
No, I'm not saying election, and I'm not really going into exactly how you're going to do it, but make sure that the people are informed and they are part of the decision making.
Which is challenging in these things, because emergency response, I can see that there is a bit of a dilemma. But in the interest of time, Thor, I'd like to come back to one final point, if you don't mind, and that is the swelling that's going on right now on the Reykjavik Peninsula. People have been expecting an eruption for some month now. So what's your take on things, just to conclude here? Will we have another eruption very soon? Back at Sundnúkar, or do you think it might just...
Okay, here's my answer to this. Okay, so what's been happening since the start of the inflation in Svartsengi and the unrest on the Sundnúkar volcanic lineament? We've had, between eruptions or between unrest events, we have had inflation right above Svartsengi. The most direct interpretation of that is that magma has been supplied from below, and it's flowing into a shallow magma storage, sort of at somewhere between 4 and 6 kilometers depth, and that is causing the inflation. And as that thing fill up, you build up pressure in it, and if you build it rapidly enough, you might actually cause failure of the roof somewhere. And so far, that failure has always happened on the east side of that bulge. And then magma has come up between Stóra Skógsfell and Sýlingarfell on a very short fissure initially, and then we know what follows. Initially, in the early days of this process, the inflation rate was about 14 centimeters per month. Now you move to 2024, it's down to roughly about 10 centimeters per month. You move to 2025, it's down to 5 or less centimeters per month. Now it is less than 1 centimeter per month. And
yes, and this is my impression as well. It's gone very slowly.
So what does that mean? My interpretation of that is that this is a reduction in inflow rate. Right. So there's always less and less magma coming into that shallow magma storage in each successive event. And if you want to show this, you go to weather.is, type in VEDUR.is.
Don't have the right one.
Well, we can go, maybe we'll just do this. What year? Oh, you see this, I was moving.
Yeah, this is the year since last summer.
This is the current, and you can see how it's kind of flattening out.
Yes.
It's actually getting, the rate of inflation is decreasing, meaning the rate of inflow is decreasing as well. This is the whole sequence, and here is the start in 2023. And you can just see the slope of these each of these lines is the inflation.
Prior to each of the
Yes,
eruptive
yeah.
events of the last
And then you can see how this one is slow, but this one is
It's really bending, isn't it?
it's
So,
slowing down.
do you think it could just stop?
Yes, so there's definitely still a possibility of an eruption. I think as time passes, I think it's less and less likely because the inflation is going down. Inflow is eventually we go to zero, and then things won't continue. So
At zero, it's
and I think also because of the slower, and we should know that the volume that has been accumulated now is greater than the volumes in any of the previous events.
Yes.
So there's more magma volume in the storage than it has ever been before.
Right.
But why hasn't it then erupted? Why hasn't it, we have exceeded the pressure limit, right?
Yes.
But the build-up of the pressure is much, much slower because of the slower, inflation and slower influx. And maybe because of that, the overlying roof has more time to readjust to this added pressure and doesn't fail.
It may well be, and we had earlier in the discussion this idea about, transition deeper in the crust, of course, between brittle and ductile. And of course, if something heats up over time, in the surrounding of a magma reservoir, breakages will be different, fractures will behave different, and also the rock, the host rock, may be able to accommodate more magma.
And a very important thing, which most earth scientists appreciate, is that actually rock in a ductile state or magma in a ductile state, doesn't really matter, you can come from either end of it.
Yes, yes.
It's much stronger than the solidified rock or the liquid lava.
Yes, I can see that the breakage will be a lot easier.
We know this simply because, when you look at a Pauihoe lava come out, it comes out as an incandescent fluid, you start forming a crust on top of it. Within 2 minutes, you have this completely sealed in a crust, and the outermost sort of half a centimeter of that is actually brittle crust. You can see cracks starting forming.
Yes.
Underneath that, there's a ductile part, which is actually between the temperature of solidus and liquidus, so between the temperature of end of crystallization and start of crystallization. And the magma, the lava in that temperature interval has much more strength than the liquid lava in the core or the outer solidified crust, because you can stand on those Pauihoe lavas and the brittle crust is not holding up, not the liquid lava underneath it, it's actually the ductile crust. And it will hold a human being, even though it's only 2
Maybe I don't want to try that, Thor.
No one should try it.
No, you better not. Yeah,
but to illustrate how strong it is.
Yes, I appreciate
No,
that.
but please don't try that.
No, don't try that at home and listen to Thor.
It's just an example. And I think this is where we underestimate the physical properties of the liquid that we call magma. And we underestimate the strength, we underestimate how it behaves and what it can do. And the fact that we underestimate that is actually putting severe limitations on all of our modeling.
On our understanding and our forecasting.
Yes.
And as a consequence of that. Yes,
our understanding, our approach
this is
to
where-
modeling, our approach to...
This is where the basic science comes back, because it will improve all the other things on a almost perpetual or continuous basis.
So to finish this off, and now I'm rephrasing my old boss, Robin Hill, in CSIRO in Perth. If we really want to fully understand these things, we need to understand the ductile part of magma behavior.
That is certainly a true word, and great strides have been made, but I think, as you rightly point out, there's still a lot of unknowns that we have, and from the seismics to the rocks and how these things interact, of course. But I think we've covered quite a lot. I guess the key message is that people don't need to be completely overly worried in Reykjavik right now because of the earthquakes, but of course there is activity, and there will be continued rumbles. This is this part of the world, and there may also be an eruption on the Reykjanes again, but well, we'll see. Maybe there will be petering out, and the eruption will either be small or not happening. But
there's no need to worry. I mean, these things will continue happening. We just have to learn to live with these things because they're not stopping, and they're not threatening our lives. They will cause occasional disruption, but the more we know about them, the more we understand them, the more we know how to
the more we get comfortable with them, I think.
But also
knowing how to deal with it.
Yeah, deal with it. Then the impact of those events will be much less on our daily lives.
And I think that's the way to look at things for the future. But of course, to highlight the key point of the conversation, science needs more funding for that.
Yes, we need more money.
Okay, good. Thank you very much, Thor. Very much appreciated. Thank you for listening in. And I say goodbye. And well, you're going back to Iceland very soon.
Yeah.
So let's see about the eruption. And if it happens, I'll join you, of course, in due course. Thank you very much. Bye-bye. Hey, Thor.